Hi everybody, Tuesday afternoon. We're reuniting today and we're going to take care of the third video of 3 videos on 5-4. We're going to do one more mixture problem and then we're going to go to the fourth and final category of the distance problem. So here we go with the second mixture problem. It is number 5 on the list of 7 that we already emailed you in regards to the word problems. Joe Castillo, a pharmacist, needs 100 liters of a 50% alcohol solution. So the ingredient that we're talking about in number 5 is alcohol. He needs a 50% alcohol. He doesn't have it, because it says in the next sentence, he has on hand a 30% alcohol solution and an 80% alcohol solution, which he can mix together so that he can come up with his 50% that he needs. Just notice, 30% alcohol he has on hand. 30 is lower than 50. The target solution that he needs. And he has on hand 80%. 80% is higher than the 50% targeted strength that he needs. 30 is lower, 80 is higher, he can get 50, which he can mix. How many liters of each solution will be required to make the 100 liters of the 50% alcohol solution that he's going to need? So we're going to go to the setup. Step number 1. We need to find the number of liters of 30% and 80% alcohol solution, so they can then be mixed and we can get to the targeted item of 50. The chart. Column 1, amount of solution. I put in parentheses here liters because that's the label that we're talking about. Multiplied by the percent of alcohol, that's our ingredient, alcohol, is equal to amount of pure alcohol. Nothing but pure alcohol. Again, that would be given on an exam. This won't. Over here, like I already mentioned yesterday on video 2, when we did the first mixture problem, row number 1, I'm going to be consistent. Row number 1 is the lowest strength of what Castillo is going to have to use to make his targeted strength of 50%. He's going to take the lowest strength of 30. Row 2, the highest strength of 80. He's mixing low with high. And the title of the third row is his targeted strength of alcohol solution that he needs. 50%. Low, high, target, the one in between. Now let's fill in the boxes. The amount of solution of the 30%, we don't know. That's in part our question. We'll let that be X. The amount of solution of the 80% that he's going to draw from, we don't know that either. That'll be Y. But we do know the amount of solution that Joe Castillo wants in his final result of 50%. Back on that problem, it said that he needed 100. So the total is 100. It is like a total. It's just labeled as 50%. There's your first equation. X plus Y is equal to 100. We'll write it in a moment. Now the percent of alcohol that is going to be derived from each one of these containers. He's going to pull some alcohol out of a 30% container. The strength of the alcohol in this container, 30%. Over here, we express it as a decimal. We move the point twice to the left. Then he's going to another container that he has in his lab. He's going to another container of alcohol solution that is more heavily doused with alcohol, and 80% strength. We need to express that 80% as a decimal, twice to the left. And then what he is wanting at the end, he wants a 50% alcohol solution at the end. Move it twice to the left. Now people, on this one right here, those percents have been expressed as decimals. If you choose, you can get rid of those zeros there and just write 0.3, 0.8, and 0.5. But I'm not. I'm going to let it just stay that way so we can see the percents that they came from. Now, to find out the number of liters of nothing but pure alcohol, we're going to multiply the amount of solution that is in this 30% container. The amount of solution, multiply it by the strength of the alcohol, and that answer, 0.30x, is representing liters. Liters of nothing but pure alcohol. We come to the other container. If we multiply y times 0.80, we'll get 0.80y. That represents more liters of nothing but pure alcohol. This is liters of pure alcohol, more liters of pure alcohol, and in this last box, this is going to represent the total amount of pure alcohol, because this final row, we're taking the amount of solution. 100 liters is what Joe needs, and he wants those 100 liters to be at a strength of 50%, 0.50. So over here, I'm just going to write, for right now, 0.50 times 100. Box is done. Equation number 1, column 1. Equation number 2, column 3. Column 1, x plus y equals 100. That's number 1. Number 2, people, like we did previously on a number of problems, I don't want to have to work with decimals down here. I want to get rid of them. All of them are in hundredths. Let's move the decimals twice to the right here, twice to the right there, twice to the right there. Just do the garage. Don't touch that house, just the garage. Now we're going to have 30x here, 80y here, and now I'm going to multiply right here before we write our equation. I've moved the point. 50 times 100. 5 times 1 is 5. Add on the 3 zeros. I really don't need that anymore. I've got my 5,000. Equation. 30x plus 80y is equal to 5,000. That's number 2. Now, I believe when we did the sodium problem on problem number 4, I believe I might have used substitution. I'm going to use elimination for this one. The LCD between 1 and 30 is 30. He's already 30. I would only have to touch one equation. The LCD between 1 and 80 is 80. I would only have to touch the top equation. I'm going to again get rid of x. Tuck, tuck. He's a positive 30. I want him to become a negative 30. So if we multiply both sides of equation number 1 by negative 30, that ought to do the trick. Let's distribute. Negative 30x, negative 30y is equal to negative 3,000. Draw the line, add down, they cancel. The y's, positive 80 coupled with a negative 30, a positive 50y is equal to 2,000. Over 50, over 50. Y is equal to, well, you can cancel out the ending zeros. 200 divided by 5 would give us 40 liters of what? Well, it's Y. Let's see what Y is corresponding to. 80. 80 of 80%. Circle that. That's part of our answer. Bring down the X. Get it ready. There's no better equation to take to finish off this problem. Is number 1, the original number 1. It's the best one to take. X plus Y is equal to 100. I suppose you could get that answer without doing any work, but I'll do the work. Bring down the X and the plus sign in place of Y. 40 is equal to 100. Negative 40 on both. X is equal to 60. 60 liters of the 30%. We have our answer. So Joe is going to need 40 liters of the 80% alcohol solution, and he's going to need 60 liters of the 30. And people, just so that you kind of understand this even better, if you take those 40 liters of the 80% and the 60 liters of the 30%, and you pour those all into a big container and stir it up, mix it up very, very carefully and thoroughly, he will end up with 100 liters of the 50% strength of alcohol that he needs. Right on the money, it'll work. That's the mixture problem. Now, you now have 2 of them in the book. Now we're going to go and finish this up. And take a look at the distance problem. Now, the distance problem is a chart problem as well. The title of each column of the distance problem is going to be the 3 parts of the formula for distance. Distance is equal to rate of speed, how fast the vehicle is going, multiplied by the time that the vehicle is either going to be on the road, on the water, in the air. Distance equals rate multiplied by time. Now, before we do the distance problem, I think we need to discuss a few things about it to make sure that this will go. Item number 1, I let the distance problem be the last one that we were going to do, because in the distance problem, as opposed to the others that we've already done, the distance problem, when we come up with our system, the system will be developed from the rows, not the columns. The 2 rows, not the columns, but the rows. The other significant thing about the distance column is the fact that the problems that we're going to be dealing with are going to specify just 2 different types of transportation. Transportation by air, a plane, transportation by boat on water, traveling by water, traveling by air. Here's the significance of traveling by air and traveling by water. When we travel by air, there are 2 different pieces of our rate. You remember I just mentioned that the formula for distance is Distance is equal to rate multiplied by time. When we travel by air, there's two different parts of the rate of speed. You'll need to memorize these two pieces of the rate. There is the rate of the plane, how fast the plane is going, and then there is the rate of the wind. There is wind involved by air travel. Sometimes we call it turbulence. There is the aspect of wind when we're traveling by plane. And when we travel by a boat, there's two different parts of the rate. There is the rate of the boat on the water, and then there is the rate or the speed of the water. The water is moving. So, back to the airplane travel. This is key. When the plane is traveling with the wind, the plane will be pushed to go faster by the wind. When the plane is traveling with the wind is moving in the same direction as the plane. And if they're both moving in the same direction, the result will be the wind will push the plane to go faster. But when that same plane does an about face and is traveling against the wind promotes the fact that the wind will not aid the plane. The wind will deter the plane. The wind will make, in actuality, the plane go slower because the plane is moving into the wind and not with it. So when the plane is traveling with the wind, I want you to remember this word, addition. When the plane is traveling with the wind, addition. When the plane is traveling against the wind, slower, subtraction. Let's quickly go to the boat and then we'll do the first of two problems. When the boat is traveling with the current, there is the speed of the boat and there is the speed of the current. When the boat is traveling with the current will push the boat to go faster. So when it's going with the current, addition. When the boat is traveling against the current, it's moving into the current. There are butting heads. It'll go slower, and slower is subtraction. Now we're going to show you how it goes. We're going to do the plane first, and then we'll do a boat. Here's what it says. A certain plane flying with the wind travels a distance of 540 miles in a time of 2 hours. We know the distance and we know the time. A certain plane flying with the wind travels 540 miles in 2 hours. Later, flying against the same wind, the same plane travels 690 miles in 3 hours. When it turns around and it's going against the same wind, it'll travel a distance of 690 miles in 3 hours. Here's the question. Find the rate. Find the rate or the speed. They mean the same thing. Find the rate of the plane in still air and the speed of the wind. There's two answers that we need for number 6. We need the rate of the plane, how fast will the plane be going, and we need the rate or the speed of the wind. Now, just so that you know before I pull away from this, the 2 letters of the alphabet that I'm going to be using. When it speaks to finding the rate of the plane, I'm going to let the rate of the plane be the letter P. I'm going to stay away from the letter R. I'm going to let the P be the speed of the plane, and we're going to let the speed of the wind be W. P, W, those are the letters that are going to be used. Now, I've got to erase. We'll use a chart. 4-step plan. Let's go to number 6. Step 1. The question is asking for, I'll just make it simplified, rate of plane and wind. I'm just going to underline that letter P and that letter W because those are the letters that we're going to use. Step 2, chart. Three columns. Rate times time is equal to distance. People, we only need 2 rows. See, that's different from the others. We only need 2 rows. I'll give you that. Now here we go to the title of the rows. We're dealing with only one plane, but the plane is going in 2 different directions, so we're going to let row number 1 be with the wind. On its journey, it's traveling with the wind, and when it does an about face, it's going against the wind. Just remember these words, with and against. With means together. That means the wind is going to push the plane to go faster and reach its destination faster. When the plane does an about face and is flying into the wind, against the wind, against means slower, subtraction. So I want you to do this. This is going to be a key piece to this problem. The rate column. I want you to come to the box under rate that is dealing with the wind. With, the wind is going to help it to go faster, and faster is addition. I want you to put a plus sign right here. It'll go faster when it's traveling with the wind. Now here's the key thing. Got to do this in the right way. Here's where our 2 variables are going to go. The variable that goes first is always the rate of the vehicle. So I'm just going to write the word plane right here. And I'm going to put the other rate aspect here, wind. So now let's put in our letters. The overall rate of speed for the plane traveling with the wind is plane, P, plus W. The wind will push it to go faster. Let's go to the rate box against the wind. That's minus, because the plane's going to go slower. You must put the plane variable first. It says so. W second. People, make this notation. You cannot put W first. It must be the vehicle first, plus or minus wind. Now the rest we all know. The problem said, flying with the wind, he travels 540 miles in 2 hours. With the wind, he's going to travel a distance of 540 miles in 2 hours. Time, 2. Distance, 540. There's the rate, P plus W. Later, flying against the same wind, it will cover a distance of 690 miles, and it's going to take a total time of 3 hours. The chart is done. Now notice what I said at the beginning of my original introductory comments. The system will never be developed by columns. The system will be developed by rows. Row number 1 is going to give us equation number 1. Row number 2 is going to give us equation number 2. Let's write down the first equation. Rate multiplied by time equals distance. Here's the rate, there's the time. We have to set these up to mean multiply. We are not going to put the P plus W down first because it's a binomial. We're going to kind of interchange these variables and commute a little bit. And we're going to write time first. Time multiplied by rate is equal to distance. So we're going to begin with the time element. Equation number 1. 2 times the quantity of the overall rate, P plus W, is equal to its distance, 540. That's number 1. Number 2, likewise, we're going to start with the time. We're going to multiply it by this overall rate. I want you to notice I'm leaving some space. You're going to see why in a moment. 3 times the quantity of P minus W is equal to 690. There's number 2. Now, people, here is what ordinarily would happen when we do the next step. We would ordinarily have to distribute to get rid of the parentheses on this side of this first equation, and we'd have to do the same thing on the second. But I'm going to give you this statement in a moment. We're not going to distribute. Would you look up here on this left-hand side? If there is some way that I can get rid of this distributor factor of 2 and this distributor factor of 3, if there were a way that I could get rid of these 2 factors right here, let me cover them up lightly. Look at this left-hand side that would be left. Look at the W's. The coefficients of W are opposite. They'll cancel out by using elimination. That's what we're going to do. Here's the word that I want to give to you. Here's the phrase. When you get down to the system, don't distribute, divide. Don't distribute, divide. Equation number 1. To get rid of this unwanted factor of 2, because remember there's a dot there. To get rid of that unwanted factor of 2, we're going to divide both sides by that 2. So you can just make another little line right there, over 2 and over 2. Let's do the same thing with the number 2. I want to get rid of him. He's a little factor. Divide the left by 3 and divide the right by 3. Now let's bring down our brand new system. They cancel. You're left with P plus W is equal 540 divided by 2 will give us 270. The second one, they'll cancel. We're left with P minus W is equal to, divide 690 by 3, and that will give us 230. Here's the brand new system. Ignore this one now up here. That was the initial one that we got from the chart. This is the one that we're going to work with. We're going to use elimination because look at the coefficients of W. They're in standard form and the W's will cancel out. Draw a line. Add the A expression with the C. 1P added to 1P, 2P. Add the B with the D. That should give us 500. Over 2. Over 2. The speed of the plane will be 250 miles per hour. So we have the speed of the plane. Now we need the wind. Now we need W. People, don't go up here. Don't look at these anymore. You look here. You pick one of these. One of these. This is a good one. Now let's substitute 250 in place of that P. Subtract 250 from both, and we'll get W is equal to a wind speed of 20 miles per hour. Speed of plane, speed of wind. That's the distance problem. That one was dealing with a plane. All right, I'm going to erase it, and we're going to do the boat. And the boat isn't going to be any different. The letters will change a bit, but it isn't going to be that different. Same kind of an idea. Here we go. It takes a boat 1.5 hours to go 12 miles downstream. People, you can make this little note. Downstream means with the current. It's not always going to say with the current. It could say downstream like this one does. Downstream is with current. It's going to go faster. And 6 hours to return upstream. Upstream is going against the current. The boat's going up, the water's coming down on it, it's going to go slower. 6 hours to return upstream. Find the rate of the boat in still water and the rate of the current. Here's the variables I'm going to use. For the speed or the rate of the boat, I'm going to use B. For the speed or the rate of the current, going to use C. The second and the third letters of the alphabet, B and C. Step number 1, we need the rate of boat and current. How fast is the boat traveling and how fast is the water moving? Same chart. Same 1 and 2 over there. Title of row number 1. I'll use the words that were used in the problem, and I'll give you a couple of things here. Row number 1. Downstream. Now, just so that you know the synonym for downstream, I'll put this in parentheses. It didn't use these words, but it means it. Downstream is with the current. Other, upstream. It's going up. That's against current. Here, the boat must be first. The current must be second. When it's traveling downstream or with the current, it's addition because the current will push the boat to go faster. But when it's going upstream, it'll go slower. Let's fill in the rate box. Downstream. Speed of boat, B, plus C. Going against the current or upstream, boat, but minus C. It's going to go slower. It's got to work harder. The time, well, here we go. It takes a boat 1.5 hours to go 12 miles down. Down. 12 miles, 1.5 hours. 6 hours to return. 6 hours to return upstream, same distance. There it is. Equation number 1, row number 1, beginning with time times the overall rate. 1.5 times the quantity of B plus C is equal to 12. Row 2, 6 times the quantity of B minus C is equal to 12. Number 2, we're not working with those. We are not going to distribute. We're going to divide. We're going to divide number 1, both sides, by that distributor of 1.5. I'm not even going to move it here. We'll just divide it because you've got your calculator. This one, we're going to divide both sides by 6. I'll just put another number 1 right here and a number 2. The top one, they go. We have B plus C. This side, I'll show the division. 12 divided by 1.5. You got to move the decimal point on that divisor over 1. Then you have to move the decimal point of where it is on the 12 right now, which is right there. It has to be moved over 1. You're going to have to add a 0 and move it. Bring it up. If you divide 15 into 120, it's going to go exactly 8 times. So 8. The second one, faster. B minus C is equal to 12 divided by 6, which is 2. There the old. This is the new. Look at the coefficients of current. They're opposites. Draw the line. Add down. 2B is equal to add over 2 over 2. B, the speed of the boat, 5 miles per hour. Now let's get the current. Pick one of these. Don't do any of those. One of these. It's a good one. Boat is 5. 5 plus C is equal to 8. Negative 5, negative 5. The current is 3 miles per hour. Just let it stay in that way, and that is fine. Okay. Now we have now completed 5-4. Now folks, just a few comments before we sign off today. I had sent you an email and I said, now we will complete that entire assignment that we handed and delivered out to you. Now we can do all 18 problems. Now we can do all 18. Now we'll stay in touch with you as this week moves on. Chapter 5 is done. When we reunite later on this week, as we move into Chapter 6, we'll be moving into polynomials. And I can tell you right now, just so that you can kind of maybe see some light at the end of the tunnel, our second exam will cover Chapters 5 and 6. We are not doing Chapter 2. Chapter 7 will be done after. Our next exam of 100 points will cover 5 and 6. Don't worry about that date yet. I'm just letting you know that it is going to be those 2 chapters. Now I'll touch bases with you a little bit later on with a newer email that will supply a little bit more information. But we'll sign off right now, and it's good to be in touch with you folks. You take care of yourself. Goodbye.